This intro sets the viewer's expectations for a deep dive into the engineering behind Apple AirPods. It highlights why these small devices are technological marvels and teases the miniaturized internal components, sensors, microphones, acoustic structures, and wireless systems that work together to create Apple's signature audio experience. The intro builds curiosity, emotional engagement, and sets up the viewer for a long, cinematic explanation that fits perfectly with a faceless tech channel format. Imagine slipping a pair of sleek, minimalist AirPods into your ears and instantly being transported into a world filled with crisp highs, rich mids, and deep, satisfying bass, all wrapped inside a wireless ecosystem that feels almost magical. Yet behind that effortless experience lies an intricate and fascinating world of microengineering, precision manufacturing, and technological innovation. And today we're going deep inside Apple AirPods. Tiny engineering secrets that make music sound bigger, exploring every hidden chamber, every microscopic component, and every intelligent design choice that turns Apple's tiny earbuds into one of the most iconic pieces of consumer tech ever created. Because while AirPods look simple on the outside, the internal engineering is nothing short of extraordinary, beginning with miniaturization, the core philosophy behind their construction, where Apple engineers pack a powerful microspeaker driver, multiple MEMS microphones, a lithium-ion scroll, style battery, a custom audio chipset, optical sensors, accelerometers, antennas, vents, meshes, and heat management structures into a casing that weighs just a few grams, an engineering achievement made possible by manufacturing innovations like photolithography and silicon wafer engineering, allowing components to shrink down to unimaginable sizes without sacrificing reliability. And this miniaturization enables the tightly packed internal layout where everything from the speaker to the microphones to the sensors must work flawlessly in extreme proximity, yet still deliver clear audio, stable connectivity, and responsive interaction. And speaking of power, one of the most impressive internal components is the tiny 182 mAh lithium-ion battery, designed in a scroll-like structure that maximizes energy density while staying flexible enough to fit inside the narrow AirPod stem. A battery that must balance high performance with minimal power draw, and despite its compactness, it delivers hours of playback thanks to Apple's advanced power management system, which intelligently distributes energy between the microphones, sensors, Bluetooth chipset, and audio driver, ensuring that every milliwatt is used efficiently. Though like all lithium-ion cells, it experiences gradual degradation due to heat charge cycles and environmental conditions, yet even with these limitations, it remains one of the most sophisticated micro batteries used in consumer wearables. Now let's dive deeper into the Bluetooth architecture. Because AirPods rely on a highly optimized 2.4 GHz wireless system using adaptive frequency hopping to avoid crowded signals from Wi-Fi routers, smartphones, and other Bluetooth devices, ensuring stable connectivity even in busy public environments. And this system works hand in hand with a strategically placed antenna embedded inside the AirPod stem, allowing stronger signal reception and fewer dropouts, while Apple's custom chipset improves, pairing speed, latency, and smooth device switching across the Apple ecosystem, creating the seamless audio handoff that users love, giving the impression that AirPods simply know what device you want to listen on. But wireless connectivity is just one part of the puzzle, because the remarkable sound quality AirPods produce depends heavily on their intelligent microphone system, powered by MEMS, micro-electromechanical systems, microphones, small enough to sit on a pin yet powerful enough to capture voice with clarity while filtering out unwanted noise. And AirPods use multiple microphones, some pointing outward for noise analysis and others pointing inward toward your ear canal to enable voice isolation, directional beamforming, and active noise cancellation, making sure your voice sounds crisp whether you're on a call, giving Siri a command, or recording a voice note. And these microphones collaborate with Apple's noise-canceling algorithms to analyze your environment thousands of times per second, determining what sound should be suppressed and what should be kept. And this brings us to noise cancellation, one of AirPod's signature features, achieved through a combination of feed-forward and feedback microphones, where feed-forward mics detect external ambient noise and cancel it before it reaches your ears, while feedback mics monitor residual noise inside the ear and make real-time adjustments to maintain consistent cancellation, creating a deeply immersive, listening environment even in noisy places like airplanes or city streets. And to further refine the audio experience, Apple designed precise acoustic system with tiny vents and black meshes that regulate air pressure and optimize airflow, working alongside hydrophobic coatings that protect internal components from moisture and debris while still allowing sound to pass through. And these vents also prevent the plugged ear, feeling common in many earbuds, ensuring comfort even during long listening sessions. While the acoustic tuning aligns with a Harman target curve to deliver balanced sound with rich bass, clean mids, and smooth treble, making AirPods suitable for both casual listeners and audiophiles who appreciate detailed sound. And none of this would work without the sensors and intelligent features baked into the AirPods' tiny frame, such as accelerometers that detect jawbone vibrations to activate Siri efficiently with low power, optical sensors that detect when AirPods are inserted or removed, enabling automatic pausing and resuming of audio, and motion sensors that help with spatial audio calibration, device switching, and gesture controls, creating a seamless and intuitive interaction experience where AirPods feel almost alive, responding instantly to your movement and commands. And behind all these features lies the manufacturing brilliance that makes such microengineering possible, because creating AirPods requires techniques normally reserved for advanced electronics like CPUs and medical devices, including silicon wafer engineering to carve out microscopic components, laser-based bonding methods to secure delicate structures, and precision assembly robots capable of placing components smaller than a grain of sand with near-perfect accuracy. And this manufacturing excellence not only enables a compact design, but also ensures durability, allowing AirPods to withstand daily use, sweat, minor impacts, and environmental stress while maintaining performance. But what truly elevates AirPod above many other earbuds is their harmonious integration of all these technologies, miniaturization enabling powerful hardware, hardware enabling advanced sensors, sensors enabling intelligent features, and all of it working together to create an experience that feels simple yet deeply engineered. And as we step back to appreciate the full picture, we see how AirPods have reshaped consumer expectations for wireless audio, proving that small devices can deliver big sound, powerful noise cancellation, seamless connectivity, and intuitive interaction, all wrapped in Apple's design language of simplicity and elegance. And after understanding all these tiny engineering secrets, the big question remains, are AirPods still worth buying in 2025? The answer is yes if you want unbeatable ecosystem integration, stable wireless performance, reliable microphones, intuitive sensors, balanced tune audio, and a comfortable design, making them perfect for students, professionals, travelers, content creators, and everyday users. But if you prefer customizable sound signatures, more battery life, or more rugged designs, other earbuds may fit your needs better. Yet AirPods remain the king of seamless experience and engineering finesse. And with that final recommendation, we wrap up this deep engineering exploration. Don't forget to like, subscribe, and stay tuned for more tech deep dives only on TechVerse.